David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Today's topic, factoring review. So we've been working through this factoring chapter for a little while now. I want to do a video that goes over all the techniques that we did in that chapter. Now, I'm going to provide just basically one example for every technique. You should know that you have many problems in our textbook that you can practice on. Okay, so the first one, the most basic factoring, is taking out a GCF, which is a greatest common factor. So an example problem for this might be 6x squared minus 9x. And what you have to do is you have to look for the biggest factor that's in both of these. And in this case, I've got a 3 in both the 6 and the 9, and then I have an x in both the x squared and the x. So my greatest common factor is 3x. So I factor it out, and I put my parens because I got to put what's still in there after I factor out the 3x. So another way to look at that is, what times 3x gets us to 6x squared? And that would be 2x minus, and how do I get from 3x to 9x? That would just be 3. So that's a GCF factor. Okay, now in that, we had a couple problems that were a little bit more complex, like this one. It might not look like a GCF factoring, but it is. So that's why I wrote expand first, then factor. So the expansion I want to talk about is this one here. X minus 5 squared can be just written as x minus 5 times x minus 5. Bring this down. So I just took this, wrote it as the binomial squared that it is. And now, again, this is a little harder to see, but my greatest common factor is my x minus 5. I have two of them over here, so that's what makes it confusing. But what we can do is we can take out this x minus 5, and what's left? We have x minus 5 and the minus 2. Finishing up, x minus 5 times x minus 7. Okay, our next pattern was the difference of squares. And let me put up the basic pattern. That's when we have a squared minus b squared. That's going to equal a plus b times a minus b. So that's the basic pattern that we're using with these problems. So when you look at one of these, you need to notice that this is a perfect square and that's a perfect square. So my a from the pattern over there is x, and my b is going to be the square root of this number, so I can use it in the pattern. So what's the square root of 169? 13. So this becomes x plus 13 times x minus 13. Now this one's a little bit more complicated, not too much. Why don't you pause the video and see if you can do that? Okay, so there's a step here. Notice how I don't have a number in front of my x squared term, so that makes that nice and easy. It's just x. Now I have a number, but that number is special. 4 is also a perfect square. So I can rewrite this as 2x squared minus 49. So this is going to end up generating a 4x squared if I were to apply the power to the two parts of this term in the parentheses. But I don't want to do that because now I know my a is 2x and my b is the square root of 49, which is 7. So what we get is 2x plus 7 times 2x minus 7. Okay, now let's do the perfect squares pattern. So I wrote up the general pattern here. You got that in the lesson. That's if I have a squared plus twice times a times b plus b squared, it ends up being this binomial squared. And it's almost identical for the minus, it's just that you end up with a minus in there. Otherwise, these two patterns are pretty much the same thing. Now this one's the tricky one. What you have to be able to do is recognize the 2ab term in the middle. The other thing is that you can tell this is not a difference of squares pattern because we have a middle term. Difference of squares does not have middle term. Okay, so what's my a here? My a would be, this term is a squared, x squared, so a is x. A equals x. What's my b? It will be the square root of the 9. So my b is 3. So this term has to be 2 times a times b. So if I can rewrite 6x as 2 times x times 3, I'm in good shape. And guess what? 6x is 2x times 3. That's 6x. So now I can use my a and my b here and just do x plus 3 squared. Okay? Now, if you're not sure, you can always FOIL this. You can always do x plus 3 times x plus 3, track your terms, and you should wind up right back there. Okay, now this one is a little bit harder. I had some feedback that people struggled with some of these ones, so I wanted to give you a chance to practice that again. You might want to, oh, check this out. That should be squared. So you might want to pause the video and see if you can do that. Okay, let's see how you did. But first, if you struggled to get started on that, let me give you a tip. There's a GCF in each of these 3 terms. So you can factor that out, and then you can use the perfect squares. So go ahead and pause the video again and see if you can do that. Okay, so let's do that. 2 times x squared minus 12x plus 36. I just factored a 2 out of each of the 3 terms, and that wound up with a 2 on the outside, and then what's left inside. Now this is a perfect square. My a is x, my b is the square root of 36, which is just 6. So it's 6 times 2 times x, and that does give us 12. So what we can do here is 2 times x minus 6 squared. Now there's a couple things I can also say. That the term in here is always half of the middle term. Notice how that happened here. The middle term was 6, the term in here is 3. So that's something that you should also wind up with when you do these. Okay, now we're going to look at the factoring 4 terms. And this was an intermediate step to getting to the split the middle terms factoring. So this helps you build the skills necessary to do that. So we have 4 terms. The trick here is we want to pair them up like 2 terms and 2 terms that each have a nice GCF in them. So often the first step for these problems is to rearrange the 4 terms that you have. And so take a look at those and see if you'd like to rearrange them or not. Okay, if you decided to rearrange them, you were right. There's no GCF in these 2. I can't take anything out of both of these. There is an x in this one, but it's not going to be super helpful if I can't get something out of here. So what I'm going to do is I'm going to bring this 10x over and do 2x squared minus 10x, because there's a 2x in both of these. That's a nice big GCF. Bring down what I have left, my 3x and my minus 15, and that's also nice because there's a 3 in both of those. So we're going to be good to go with this one. Okay, so my GCF here is 2x. That leaves me with an x there minus 5. So that's the GCF factoring of this pair. Now let's bring out, we have a 3 in there. 3 times x minus 5. And guess what? We know we did this right because these 2 terms are the same. That's what we need. So now I can just do 2x minus 3, plus 3 times x minus 5. And we're done. Okay, so let's do split the middle term. And you need to do this one when your a term doesn't equal 1. And what I mean by a term is this number that's in front of the x squared. If this isn't 1, then you need to use the split the middle term factoring technique. And when you see a factoring problem that has a number out here in front of the x squared, your first step should always be, can I factor this 8 out of 22x and out of 15? Because then I can remove the need to split the middle term. However, in this case, I can't do that. There's no 8 in 22 and certainly not in 15. So I have to split the middle term. So our first step with that was to figure out what a times c is. So AC equals 8 times 15. What do we get for that? 120. Now I need 2 factors of 120 that add to the middle term. So 2 numbers that multiply up to 120 but add up to 22. And I could go through all the factors, but what I'm going to show you here is that 10 times 12 equals 120, and 10 plus 12 equals 22. So those are my two factors. So now, what I do is I split this middle term using 10 and 12. 8x squared plus 12x plus 10x plus 15. This expression is still the same as this one. I just took this 22x and divided it into 12x and 10x. I also did it with the 12x first because there's a bigger common factor in these two. And if I put the 10x there, it's not quite as big. It would still work, but I like to get the biggest common factor out of each pair. So now what I do is I've got a factoring with 4 terms problem, like that last technique that we did. What's my greatest common factor in here? 4x. So this is 4x times 2x plus 3. What's my GCF in here? I just have a 5. This becomes 5 times 2x plus 3. And I know I did this right because the factors in parens are the same. So now I can just do 4x plus 5 times 2x plus 3. Okay, the last pattern we covered is the product sum factor pattern. These ones don't work for any of the other patterns. So I do have a middle term, so we know it's not a difference of squares. And these ones are easy to solve if you just realize one thing. You're looking for two numbers that multiply to the end and add to the middle. Okay? So we take a look at the factors of 12. I can do 1 times 12. That's not going to add up to 7. That could be 13 maybe, but not 7. How about 2 times 6? That makes 12 also. But 2 and 6 are never going to add up to 7. How about 3 times 4? 3 times 4 is 12, and 3 plus 4 is 7. So I'm going to write that out here. 3 times 4 equals 12, and 3 plus 4 equals 7. So my two factors are 3 and 4. This step is super simple. You just do x plus 3 times x plus 4. And that takes care of that. Now, if you're unsure, you can FOIL this, you can expand it, and you should wind up right back there as a check. So if you're ready, try this one. This one's similar. You'll notice that there's a minus on the middle term, so that's going to change a little bit about what you do, but it's the same process that we just went over here. Okay, let's see how you did. I need two factors that multiply to 48 that add up to negative 14. So what I would do, this is an even number, so I can start dividing by 2 and see what happens. So 2 times 24 is 48. Negative 2 times negative 24 is also positive 48. And I went to negative because I know I need a negative middle term to make this work. But negative 2 and negative 24 are never going to get you negative 14. So I'm going to skip to the chase. 48 can be obtained by multiplying negative 6 times negative 8. That's positive 48. And negative 6 plus negative 8 equals negative 14. So my two factors are negative 6 and negative 8. Now I just go straight to this step, x minus 6 times x minus 8. And that's the factorization of that one. Remember, you can check it, you can FOIL that, and you should wind up back at that. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.